Hello everybody, today I'll be considering the operation principles of ships, that is the principles guiding the operation of ships. The operation principles of ships involve various aspects of marine engineering and navigation to ensure safe and efficient transport over water. So here is an overview. The first principle I'll be considering is buoyancy. Buoyancy. Buoyancy is a critical principle that allows ships to float. It is based on Archimedes' principle, which states that any object submerged in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. Ships operate based on the principle of buoyancy, that when an object is submerged in a fluid, the object is buoyed up by a force which is equal to the weight of the fluid displaced by that object. Now, for a ship to float, there must be displacement, in the sense that the ship must displace a volume of water which is equal to its own weight. As a ship is placed in the water, it pushes water aside, and the displaced water creates an upward buoyant force. That is, when the ship is moving in the water, it will be pushing water aside, and the water that is displaced creates an upward buoyant force. It is this upward force that keeps the ship floating. Another thing that is important is the hull design. The hull design. Ships have hulls designed to maximize buoyancy. The hull's shape ensures it displaces a sufficient volume of water, creating enough buoyant force to support the ship's weight. Because the weight of the ship is acting downwards, so there must be enough buoyant force to keep the ship floating, because there will be cargo and there will be passengers and many other things loaded on the ship. So the hull design must be such that it maximizes the buoyancy, creating sufficient buoyant force to support the ship's weight. Number 3 is density. For a ship to float, the overall density of the ship, including its cargo and structure, must be less than the density of water. This is achieved by constructing ships with large hollow spaces and materials that are less dense than water. For a ship to float, what's density? Density is mass divided by volume. The overall density of the ship, including the cargo and structure and every other thing that will be loaded on the ship, the overall density of the ship must be less than the density of water. And this may look somewhat difficult, but it's achieved by constructing ships with a large hollow space and materials that are less dense than water. Next is the stability. To remain stable, ships have a low center of gravity and wide beams. This design helps them to resist capsizing and maintain equilibrium on the water. Stability of ship is very, very important. Ships are designed to have a low center of gravity and wide beams. This design helps them to resist capsizing and to maintain equilibrium on the water. The next I'll be looking at is the propulsion and power supply. Power supply and propulsion in ships are fundamental to their operation and efficiency. How are ships propelled? What's the power supply they use? Let's have an overview. Marine engines. The major source of power in most ships is the marine engine. These engines can be diesel engines, it could be gas turbines, it could also be steam turbines. The primary source of power in most ships is the marine engine. For diesel engines, is the most common type of engine, known for their efficiency and reliability. Gas turbines, they are used in some naval and high-speed vessels for their high power to weight ratio. They have high power to weight ratio. And steam turbines, they are less common today, but still used in some ships, especially in older vessels. For older ships, some of them still make use of the steam turbine. Then the electrical systems. Ships have extensive electrical systems powered by generators, which are often driven by the main engines or auxiliary engines. And this could be alternating current systems or direct current systems. For the alternating current systems, it is used for most of the ship's electrical needs. And for the direct current systems, it is used for specific applications like battery charging and emergency systems. Number 3, Auxiliary power units, APUs. APUs are secondary power sources used to provide electrical power when the main engines are not running, such as when a ship is docked. The auxiliary power units, they are secondary sources of power used to provide electrical power when the main engines are not running, such as when a ship is docked. Now the propulsion. I've looked at the power supply. Now the propulsion. The number one type of propulsion system is the propellers. Propellers are the most common propulsion method. It could be fixed pitch propellers or variable pitch propellers. For the fixed pitch propellers, blades are fixed and do not change their angle. The blades are fixed and do not change their angle, while for the variable pitch propellers, blades can change their angle to optimize performance. The variable pitch propellers have blades that can change their angle to optimize performance. Next is water jets. Water jets are used in high-speed vessels. They draw water from under the hull and expel it at high speed to propel the ship forward. That's another system of propulsion. It's used especially in high-speed vessels. Water jets, this means water is drawn from under the hull and water is expelled at high speed to propel the ship forward. Number 3, electric propulsion. The use of electric motors to drive the propellers. This can be more efficient and allows for flexible engine placement. So this could be in form of diesel electric propulsion or battery electric propulsion. In diesel engine propulsion, diesel engines generate electricity which then powers electric motors connected to the propellers. For the battery electric propulsion is increasingly used in smaller vessels and ferries, with batteries providing the main source of power. Batteries provide the main source of power here. Nuclear propulsion is primarily used in naval ships and submarines. Here, nuclear reactors generate heat to provide steam, which then drives turbines connected to the propellers. Nuclear reactors generate heat, which will produce steam, and the steam drives turbines connected to the propellers. Sails and hybrid systems. There are some modern ships that make use of sails or kites to harness wind power, reducing fuel consumption and emissions. This involves making use of sails or kites to harness wind power, reducing fuel consumption and emissions. Now let's look at the efficiency of these power supply and propulsion systems, as well as the environmental considerations involved. The first is fuel efficiency. Modern ships aim for high fuel efficiency to reduce operational costs and environmental impact. This involves optimizing engine performance, the hull design and route planning. Next, emission control. Ships are increasingly equipped with technologies to reduce emissions, such as scrubbers to remove sulfur from exhaust gases and systems to reduce nitrogen oxide emissions. And also the use of alternative fuels. The shipping industry is exploring alternative fuels like liquefied natural gas, hydrogen and biofuels. Now all those are to reduce emissions. Now the third operation principle is the hull design and stability. Hull design and stability. What is the hull? The hull is the watertight body of a ship, and its design is critical for buoyancy, stability and efficiency. Its design is very important for buoyancy, stability and efficiency. The key aspects include the following. First is the shape. This involves displacement hulls, planing hulls and semi-displacement hulls. Displacement hulls is the most common design to displace water and provide buoyancy. It's suitable for larger ships like cargo vessels and cruise ships. For the planing hulls, is designed to rise and glide on top of the water at high speeds. Is used in smaller and faster vessels. And for the semi-displacement hulls, it combines features of both displacement and planing hulls, providing a balance between speed and load carrying capacity. It provides a balance between speed and load carrying capacity. Next is materials. This involves steel, aluminum, fiberglass and composites. Now for steel is the most common material used for larger ships due to its strength and durability. Steel is used for larger ships due to its strength and durability. Aluminium is used for faster vessels and smaller ships due to its light weight. It's used for faster vessels and smaller ships. And as for fiberglass and composite, it's used in smaller boats and yachts for their lightweight and corrosion resistance. Fiberglass and composite are mainly used because of their lightweight and corrosion resistance. Now, hydrodynamics. Hulls are designed to minimize resistance through water, improving fuel efficiency and speed. Hulls are designed to minimize resistance through water and to improve fuel efficiency and speed. This involves bulbous rows, protrusions at the front of the hull that reduce wave resistance and improve fuel efficiency, and also streamlined shapes, curved designs to reduce drags. Hulls have streamlined shapes to reduce drag as it moves through the water. Yeah, so that's it for the design. Now let's consider the stability. Stability of the hull ensures that a ship remains upright and balanced in the water. It's crucial for safety and performance. The key factors here include the following. First, the center of gravity is the point where the ship's weight is concentrated. A lower center of gravity provides better stability. And also we have the center of buoyancy, the center of the volume of water displaced by the hull. The relationship between the center of gravity and center of buoyancy determines the stability. For the stability of the ship, we have to take the center of gravity and center of buoyancy into consideration. Number 3, the metacentric height. The metacentric height is the distance between the center of gravity and the metacenter. That is the point where the buoyancy force acts when the ship is tilted. A larger metacentric height indicates greater stability, but too large a metacentric height can make the ship uncomfortable due to rapid rolling. Now let's consider some types of stability. We have static stability, we have dynamic stability. Static stability is the ability of a ship to return to an upright position after being tilted by a static force, such as cargo shifting. Dynamic stability is the ability of the ship to return to an upright position after being tilted by dynamic forces, such as waves and winds. How can the stability be enhanced? It can be enhanced by making use of ballast, which involves adding weight such as water or solid materials low in the hull to lower the center of gravity. A ballast is an heavy material that is placed in the hold of a ship to provide stability. We can also make use of wide beams, that is, increasing the width of the ship to improve stability. Increasing the width of the ship to improve stability. Still on enhancing stability, number 3, the keel design. The keel running along the bottom of the hull can be designed to provide additional stability. The keel is a large beam along the underside of a ship's hull, and it can be so designed to provide additional stability. Number 4, stabilizers, fins or other devices that extend from the hull to reduce rolling motion. What are the modern innovations in hull design and stability? The first is the advanced hull forms. Designs like the SWAT, that means small waterplane area twin hull, and catamarans, they offer improved stability and efficiency. It can also be in form of computational fluid dynamics (CFD), which is used to simulate and optimize all performance and stability. It's used to simulate and optimize all performance stability. Number 3, active stabilization systems. That is, computer control systems that adjust stabilizers or ballast in real time to maintain stability. These are active stabilization systems, computer control systems that adjust stabilizers or ballast in real time to maintain stability. Let's consider next navigation and control systems. Ships navigation and control systems. First, the navigation systems. It makes use of global positioning system (GPS). This provides precise location data using satellites. Is the cornerstone of modern navigation, allowing ships to determine their exact position, speed, and course. Allowing ships to determine their exact position, speed, and course. Then number 2, radar is used to detect other vessels and obstacles. It's particularly useful in poor visibility conditions. Radar helps in collision avoidance and navigation decision making. It helps in collision avoidance and navigation decision making. We also have the automatic identification system, AIS. This transmits a ship's identity, position, course, and speed to other ships and shore stations, enhancing situational awareness and collision avoidance. The automatic identification system transmits information about the ship, such as identity, position, course, and speed, to other ships and shore stations to enhance situational awareness and collision avoidance. Number 4, electronic chart display and information system. Electronic chart display and information system is an advanced navigation tool that displays electronic navigation charts and integrates data from various sensors. It helps in route planning, monitoring, and execution. We also have the gyro compass, which provides true north readings unaffected by magnetic fields. Is crucial for accurate navigation and autopilot system. Number 6, the use of magnetic compass is a traditional tool that indicates magnetic north. It serves as a backup to the gyro compass. Number 7, depth sounders and sonar. Depth sounders and sonar. These measure water depth below the hull to avoid running aground and to assist in navigation through shallow waters. It measures water depth below the hull to avoid running aground and to assist in navigation through shallow waters. Now let's consider some control systems used in ships. The first is the autopilot system. It automatically steers the ship along a predetermined course. Modern autopilots can adjust for wind, currents, and other variables, reducing the workload on the crew. The autopilot system automatically steers the ship along a predetermined course, and there are some modern autopilot systems that can adjust for wind, currents, and other variables, reducing the workload on the crew. Number 2, the use of dynamic positioning system, DPS. This maintains a vessel's position and heading automatically using thrusters and propellers. It is essential for operations requiring precise positioning like offshore drilling and cable laying. The dynamic positioning system. Number 3, integrated bridge systems, IBS. These combine various navigation and control systems into a single interface. This integration allows for easier monitoring and control of the ship's operation from the bridge. And then we also have the engine control systems, which monitor and manage engine performance, fuel consumption, and emissions. They ensure efficient operation and can automatically adjust settings based on current conditions. Number 5, steering gear systems. These include hydraulic or electronic actuators that control the rudder based on commands from the aim or autopilot. We also have the alarm and monitoring systems. They track various parameters such as engine performance, fuel levels, bilge water levels, and so on, and alert the crew to any issues that need attention. What are the modern innovations in navigation and control systems of ships? The first is the use of artificial intelligence and machine learning. They are used for predictive maintenance, optimizing routes for fuel efficiency, and enhancing decision-making processes. Number 2, remote and autonomous navigation. Emerging technologies enable remote control of ships from shore or autonomous navigation with minimal human intervention. These systems use a combination of sensors, artificial intelligence, and machine learning to navigate and operate the ship safely. Number 3 is augmented reality, which displays on the bridge, providing real-time data overlays on the physical environment and also enhance situational awareness and decision making. And lastly, the Internet of Things. This connects various ship systems and sensors to a central network, allowing for real-time data collection and analysis. This connectivity supports better decision making, predictive maintenance, and operational efficiency. The Internet of Things connects various ship systems and sensors to a central network, allowing things such as real-time data collection and analysis. This connectivity supports better decision making, predictive maintenance, and operational efficiency. Moving on to the fifth principle I'm going to talk about, that's about the safety systems. Safety systems on ships are critical for protecting the crew, passengers, cargo, and the vessel itself. These systems encompass various technologies and protocols designed to prevent accidents and handle emergencies effectively. The first that we are going to consider is the fire safety systems, which include fire detection and alarm systems. This could be smoke detectors, heat detectors, and manual call points to detect and alert the crew to the presence of fire. Smoke detectors, heat detectors, and manual call points to detect and alert the crew to the presence of fire. Number 2 is the use of fire suppression systems. This could be sprinkler systems that automatically activates to control and extinguish fire. It could be water mist systems, that is the use of fine water droplets to cool and smoother fires. It could be gas-based systems, the use of gases like CO2 or FM200 to extinguish fire without damaging equipment. It could also be foam systems. It is used in engine rooms and other high-risk areas to suppress fire effectively. Then we have fire extinguishers. These are portable units placed throughout the ship. It is suitable for different types of fire. Next, under safety systems, we consider the use of life-saving appliances. Life-saving appliances. Number 1 here is lifeboats and life rafts. Lifeboats and life rafts, equipped with provisions and emergency equipment designed to provide safe evacuation in case of abandoning the ship. In case there's a need to abandon the ship, lifeboats and life rafts are very important. Then we have life jackets and immersion suits. Life jackets and immersion suits. These are personal floating devices and suits that provide buoyancy and thermal protection in cold water. They are personal flotation devices and suits that provide buoyancy and thermal protection in cold water. We also have the emergency position indicating radio beacons. Emergency position indicating radio beacons. That is, you send distress signals to satellites, helping rescue teams to locate the ship in an emergency. Sending distress signals to satellites to help rescue teams to locate the ship in the case of an emergency. Then number 4, we also have the use of survival craft and rescue boats. Rescue boats. What are rescue boats? They are smaller boats used for rescuing persons in distress and transferring them to safety. These are boats. They are smaller in size and they are used for rescuing persons in distress and transferring them to safety. Now let's consider communication and navigation safety. Communication and navigation safety. The first is the use of Global Maritime Distress and Safety System, GMDSS. Global Maritime Distress and Safety System is an international system using satellite and terrestrial communication systems to ensure immediate alerting and locating of ships in distress. Is an international system using satellite and terrestrial communication systems to ensure immediate alerting and locating of ships in distress. The next is the use of VHF radio. VHF radio. This is vital for ship-to-ship and ship-to-shore communication, especially during emergencies. In the case of emergency, we can use VHF radio to communicate between ship-to-ship and between ship-to-shore. We also have the NAVTEX. That means navigational telex. Navigational telex. It broadcasts maritime safety information such as weather warnings and navigational alerts. The NAVTEX broadcasts maritime safety information such as weather warnings and navigational alerts. Structural safety. Structural safety. This includes watertight compartments, segregated sections of the hull designed to prevent flooding from spreading in case of a hull breach, We also have bulkheads and watertight doors. They strengthen the ship's structure and prevent water from moving between compartments. We have the ballast systems. These help to maintain the ship's stability and buoyancy, especially in adverse conditions. They help to maintain the ship's stability and buoyancy, especially in adverse conditions. Up next is the emergency systems. Emergency systems could include emergency lighting and power. Backup power systems ensure lighting and critical equipment remain operational during power outage. Let's say there's a power outage, the emergency lighting and power has the responsibility of ensuring that there is still lighting and that critical equipment remain operational. Number 2, emergency escape breathing devices, EEBDS. These provide breathable air for escape in smoke-filled environments. They provide breathable air for escape in smoke-filled environments. Emergency drills and trainings. Regularly conducted drills such as fire, abandoned ship, to ensure the crew is prepared for various emergency scenarios. This involves training the crew regularly on some skills such as fire and ship abandonment to ensure the crew is prepared for various emergency scenarios. Next safety system I'm going to consider is the pollution prevention, such as oil discharge monitoring and control systems. These ensure compliance with MAPOL regulations by monitoring and controlling the discharge of oily water. It could also be ballast water management systems, treated ballast water to prevent the spread of invasive aquatic species. That is, you treat ballast water to prevent the spread of invasive aquatic species. Also the garbage management plans. This includes procedures for the handling, storage and disposal of garbage in compliance with international regulations. As I wrap up this point on safety systems, what are modern innovations here? Number 1, real-time monitoring systems. Advanced systems for continuous monitoring of the ship's condition, including oil integrity, engine performance, and environmental parameters. Number 2, automation and remote monitoring. The use of automated systems to monitor and control safety equipment with remote access for shore-based support. And number 3, advanced training simulators to provide realistic training scenarios for crew members to practice emergency response in a controlled environment. Operation Principle 6 is communication systems. They are vital for ships for their operational coordination, safety, and efficiency. They ensure that the vessel can stay in touch with other ships, shore-based facilities, and emergency services. Here is an overview of the primary communication systems used on ships. The first is the VHF radio, very high frequency radio. What's the function? It is used for short range communication, typically within 30 to 50 nautical miles. The purpose: ship to ship and ship to shore communications, distress calls, and coordinating with port authorities. Ship to shore communications, distress calls, and coordinating with port authorities. Number 2, HF radio. That means high frequency radio. The function is that it provides long range communication, often used for oceanic voyages. The purpose: communicating over vast distances where VHF is not effective, such as between ships at sea and remote shore stations. It's used for communicating over vast distances where the VHF, that's the very high frequency, is not effective, such as communicating between ships at sea and remote shore stations. Next is the MF radio, the medium frequency radio. What's the function? Intermediate range between VHF and HF. It's usually used for distress and safety communications. It's the intermediate between VHF and HF, and it's usually used for distress or safety communications. The purpose is that it provides communication in areas where high frequency and very high frequency are not feasible, typically in coastal waters. Number 4, satellite communication systems. The first is Inmarsat. which offers global coverage for voice, data, and internet services. Second, we have the Iridium, which provides global coverage, including polar regions with high-speed data and voice services. And then we have the VSAT, the very small aperture terminal. This provides high-speed internet and data services using geostationary satellites. We have the GMDSS, Global Maritime Distress and Safety System. It's a comprehensive system integrating multiple communication technologies to ensure maritime safety. The components include satellite communication, the Inmarsat, VHF radio, MFHF radio, and others. So it's a comprehensive system that integrates multiple communication technologies to ensure maritime safety. The number 6 is emergency position indicating radio beacon. It transmits a distress signal to satellites in the event of an emergency. It also helps rescue teams to locate the vessel in case of an emergency situation. That's the work of the emergency position indicating radio beacon, EPIRB. Another primary communication system is the automatic identification system. It automatically transmits information about the ship's identity, position, course, and speed. It enhances situational awareness and collision avoidance and aids in tracking and monitoring by authorities. The automatic identification system is what transmits information about the ship's position, speed, course, and identity. It helps situational awareness and collision avoidance and aids in tracking and monitoring by authorities. Next is the NAVTEX, the navigational telex. What's the function? It broadcasts maritime safety information, including weather warnings and navigational alerts. Broadcasts maritime safety information, including weather warnings and navigational alerts. And the purpose is that it provides real-time information to ships, particularly in coastal areas. In the coastal areas, it helps a lot in providing real-time information to ships. Now, moving on to internal communication systems. The first I'm going to consider is the internal telephones and intercoms. The internal telephones and intercoms. Though they facilitate communication between different parts of the ship. They facilitate communication between different parts of the ship, and it allows crew members to communicate quickly within the vessel, including bridge, engine rooms, and cabins. It allows crew members to communicate within the vessel, including the bridge, the engine room, and the cabin. The second is the public address system, the PA system. It broadcasts announcements to all areas of the ship. It broadcasts announcements to all areas of the ship, and it's used for general announcements, safety briefings, and emergency instructions. It's used for general announcements, safety briefings, and emergency instructions. Number 3, data and messaging systems. Data and messaging systems. This includes the email and messaging. Ships often have email and messaging systems for communication with shore-based offices and other vessels. They often have email and messaging systems for communication with shore-based offices and other vessels, and also for ship-to-shore communication. This includes satellite phones and data terminals for direct communication with land-based facilities. Data messaging systems also help in ship-to-shore communication, which includes satellite phones and data terminals for direct communication with land-based facilities. Next, let's consider the modern innovations in communication systems on ships. The first is the use of integrated communication systems, which combine multiple communication channels into a single interface for ease of use and management. By doing this, we can simplify communication operations and we can integrate data from various systems for improved efficiency. The second is the use of enhanced cybersecurity measures. Enhanced cybersecurity measures. It can help to protect communication systems from cyber threats and unauthorized access. It can help to protect communication systems from cyber threats and unauthorized access. The purpose is to ensure the integrity and security of onboard communication systems and data. Number 3, real-time monitoring and control. Real-time monitoring and control. It can provide real-time data on vessel performance and conditions. This helps to provide real-time data on vessel on vessel performance and positions, thus allowing for remote monitoring and control of various systems, enhancing operational efficiency and safety. Enhancing operational efficiency and safety. As we move on, let's now consider environmental control and efficiency in ships. Environmental control systems on ships are crucial for minimizing the vessel's impact on the marine environment and complying with international regulations. It's very important to minimize the vessel's impact on the marine environment and to comply with international regulations. Here are some key components and technologies. The first point is the ballast water management. Ballast water management. This treats ballast water to prevent the spread of invasive species, and the technology you can use to do this is by filtration, UV irradiation, and electrochemical treatment. Also, we have the exhaust gas cleaning systems, the use of scrubbers, exhaust gas cleaning systems to remove sulfur oxides, SOx, from exhaust gases to comply with emission regulations. And the types of system we can use include the open loop, which uses seawater, closed loop, which uses recirculated water, and hybrid systems. Number 3, selective catalytic reduction. Selective catalytic reduction. As the function, it reduces nitrogen oxides, NOx, in exhaust gases using a catalyst and selective reduction agents. So it meets NOx emission standards, especially in emission control areas. We also have the use of oily water separators. So this separates oil from bilge water before discharge to prevent marine pollution, and the compliance there, it ensures adherence to MAPOL Annex regulations. So number 5 is a garbage management system. It manages the collection, storage, and disposal of waste generation on board, and it also complies with the necessary regulations. We have the hydrocarbon recovery systems. It recovers and reuses hydrocarbons from various sources, reducing waste and pollutions. It minimizes the discharge of oil and oily residues into the sea. Now let's look at efficiency technologies. All what we've just considered, this with the environment. Now let's look at efficiency technologies. The first is the use of energy efficient propulsion systems, which will enhance fuel efficiency and reduce emissions. So examples include low speed diesel engines that can optimize fuel consumption at slow speeds, and use of electric propulsions, which offers improved efficiency and flexibility in engine placement. Another factor in efficiency technology is the hull design innovations. Designing the hull such that it will reduce drag and improve fuel efficiency. Examples include the use of bulbous bows, which can improve aerodynamic efficiency by reducing wave resistance, and also the use of air lubricating systems, which reduce friction between the hull and water. Number 3, energy management systems, which monitors and optimizes energy consumption. It improves overall efficiency by managing power distribution and reducing waste. Number 4, renewable energy integration. Utilizing renewable energy sources to reduce reliance on fossil fuels, such as the use of solar panels to provide supplementary power for non-propulsion systems, and use of wind-assisted propulsions, that is, sails or kites, to harness wind energy. We also have the advanced waste heat recovery, which captures and reduces waste heat from engines and other systems. It improves overall energy efficiency and reduces fuel consumption. Now, let's consider some regulatory compliance for ships. The first is the International Maritime Organization regulations, the IMO regulations, which includes the MAPOL, that's marine pollution. Marine pollution addresses various forms of marine pollution, including oil, chemicals, sewage, and garbage. We also have the Energy Efficiency Existing Ship Index, EEXI, which requires existing ships to meet energy efficiency standards, and the Carbon Intensity Indicator, CII. This measures and reduces the carbon intensity of ships. Number 2, emission control areas. Areas that have emission controls that is designated areas that have stricter emission standards, for sulfur oxides and nitrogen oxides, and also for particulate matter. This protects sensitive marine environments from high levels of pollution. Now, as I wrap up this point, what are the future trends, the future outlook of this? The first is the use of alternative fuels, which could be hydrogen, liquefied natural gas, and so on. And number two, the use of digital twins, such as virtual models of ships used for monitoring and optimizing performance. This provides insights for improving efficiency and reducing environmental impact. And the last point is the use of autonomous ships, that is, ships that use advanced sensors and artificial intelligence to operate with minimal human intervention. It improves operational efficiency and reduces human error. Next, let's look at cargo handling. Cargo handling is also very important in the operation of ships. So cargo handling on ships is a complex process involving the loading, stowing, securing, and unloading of cargo. Efficient cargo handling is crucial for maximizing space, ensuring safety, and minimizing delays. Here is an overview of key aspects and technologies involved in cargo handling. Now, types of cargo and their handling. We have first bulk cargo. This could be dry bulk, including commodities like coal, grain, and iron ore. It's handled using bulk carriers equipped with conveyor belts, grabs, and hoppers. It could also be liquid bulk, which includes oils, chemicals, and liquefied gases. It is handled using tankers with specialized pumps, pipelines, and storage tanks. Next is the break bulk cargo. Definition: individual cargo items that must be loaded and unloaded separately. And for the handling, typically requires cranes, forklifts, and manual labor to move items like machinery, steel products, and large equipment. Number 3, containerized cargo. That is cargo packed in standardized containers such as 20-foot, 40-foot containers. And for the handling, uses container ships equipped with cranes and automated systems for efficient loading and unloading. Then number 4, the roll-on roll-off cargo. Definition: vehicles and equipment that can be driven on and off the ship. For the handling, uses specialized ramps and decks on the roll-on roll-off vessels to load and unload vehicles. The 5th, general cargo. That is, various types of cargo that are not categorized as bulk or containerized. And for the handling, typically involves specialized equipment based on the nature of the cargo, such as cranes or forklifts. Now let's consider some cargo handling equipment. The first is the use of cranes. Cranes such as ship cranes, mobile cranes, tower cranes. Ship cranes are mounted on the ship for loading and unloading of cargo. Mobile cranes provide portable cranes used in port areas. Tower cranes are fixed cranes used in dockyards, and the purpose is to handle heavy and large items that cannot be moved by other means. The second is conveyor systems. Conveyor systems is used to transport bulk materials from the dock to storage areas or hold compartments. Examples include belt conveyors, crew conveyors, and pneumatic conveyors. Number 3, the use of forklifts. Forklifts move and stack cargo in warehouses and on board the vessel. The types include electric or diesel-powered forklifts with various lifting capacities. The 4th is cargo holds and tanks. The function is, they are storage areas designed for specific types of cargo, and the features include bulkheads and ballast tanks for stability and tanks for liquid cargo. Number 5, the use of automated systems. Types include automated cranes, conveyor systems, and robotic cargo handling systems. The purpose is to increase efficiency and reduce labor costs. Next, let's consider cargo securing and stowing. The first method here is the securing methods, which could be in form of lashing, that is, using ropes, chains, or straps to secure cargo and prevent movement during transit. Then we have shoring, installing supports or braces to hold cargo in place. We also have blocking and bracing, using wooden or metal blocks to prevent cargo from shifting. And for the stowing techniques, we have the optimal utilization, that is maximizing use of space while ensuring stability and accessibility. We also have cargo plans, that is a detailed plan indicating where different types of cargo should be placed to balance the ship and prevent overloading. Next, safety and compliance. Number one, cargo handling procedures. For the manual handling, we should ensure that we follow proper lifting techniques and safety protocols. And for mechanical handling, we should ensure that equipment is well maintained and operated by trained personnel. Next, we have regulations and standards. International Maritime Organization provides guidelines and regulations for cargo handling, including the International Convention for Safe Containers and the Code of Safe Practice for Cargo Storage and Securing. We also have the port and terminal regulations that ensure compliance with local regulations and security standards at port facilities. Also, as part of safety and compliance, we have to take a look at environmental considerations as well, such as pollution control. There should be measures to prevent spills and leakage during the handling of hazardous cargo. And also for waste management, there should be proper disposal of cargo residues and packaging materials. Modern innovations in cargo handling. The first is the use of smart containers, that is containers equipped with sensors for real-time tracking and monitoring of cargo conditions to improve visibility and management of cargo throughout the supply chain. Next, we have the use of automated ports and terminals. The function is the use of advanced technologies like automated cranes, autonomous vehicles, and AI-driven logistics systems. The purpose is to enhance efficiency and reduce turnaround times. Number 3, green technologies. The function is to reduce the environmental impact of cargo handling operations. Examples: electrification of handling equipment, the use of renewable energy, and reduction of emissions. The green technologies will include electrification of handling equipment, reduction of emissions, and the use of renewable energy. Another concept that is important in the operation of ships is the dynamic positioning systems, DPS. Dynamic positioning systems are advanced systems used to maintain a vessel's position and heading automatically without the need for anchoring or mooring. They are crucial for operations that require precise positioning, such as offshore drilling, cable laying, and survey work. Let's have a detailed overview. Now let's consider the components of dynamic positioning systems. The first is the use of sensors. Under it we have GPS, Global Positioning Systems, which provides real-time position data. We also have the gyro compass that measures the vessel's heading relative to true north. Wind sensors that measures wind speed and direction. It is important for compensating drift and adjusting positioning. We have the motion sensors, which includes accelerometer and inclinometer to measure pitch and roll. The second component is thrusters, such as azimuth thrusters, that is rotatable thrusters that provide propulsion in multiple directions. They are commonly used on DP vessels for precise positioning. We have the tunnel thrusters, which are installed in tunnels within the hull, providing thrust for maneuvering and position keeping. We have variable pitch propellers, which allow adjustment of propeller blade angle to optimize thrust. The third component in the dynamic positioning system is the propulsion systems, such as main engines that drive the vessel's main propulsion units, which are integrated with the DP system. We also have the auxiliary engines that provide power to the thrusters and other equipment. The fourth component is control systems, which includes DP control units, that is the central processor that receives input from sensors and controls the thrusters and propulsion systems to maintain position. We also have human-machine interface, which allows the crew to monitor and interact with the DP system, set operational parameters, and respond to alarms. The fifth is the power management system, such as power generation and power distribution. For power generation, it includes generators and energy storage systems to ensure a constant power supply for DP operations. And for power distribution, it manages and distributes electrical power to the thrusters, propulsion systems, and control units. Operational modes, such as manual mode. What does it do? It allows operators to control the vessel's position and heading manually using the HMI, the human machine interface. And for usage, it is used in scenarios where automated control is not required or in conjunction with DP systems. For automatic mode, the function is that the DP system autonomously maintains the vessel's position and heading based on preset parameters. It is commonly used for precise operations such as drilling or cable laying. The third is hybrid mode. Hybrid mode. It combines manual and automatic control, allowing operators to intervene and adjust the system as needed. The hybrid mode combines manual and automatic control, allowing operators to intervene and adjust the system as needed. What are the benefits of dynamic positioning systems? The first is precision. It helps to maintain exact positioning and heading, which is crucial for operations like offshore drilling and surveys. I've mentioned this before. The second is safety. It reduces the risk of accidents and collisions by providing precise control over the vessel's movement. Third, efficiency. It improves operational efficiency by reducing the need for anchoring or mooring, saving time and cost. The fourth is flexibility. Flexibility. It allows operations in deep water or areas where anchoring is not feasible. It allows operations in deep water or areas where anchoring is not feasible. Now, what are the modern innovations in dynamic positioning systems? The first I'm going to talk about is advanced algorithms. The function is to improve the accuracy and responsiveness of the DP system. The purpose: enhance the system's ability to handle complex environmental conditions. The second innovation is the use of integration with other systems. By combining DP with other ship systems like navigation, communication, and weather forecasting. Combining DP with other ship systems like navigation, communication, and weather forecasting. This has the purpose of providing a more comprehensive and adaptive control solution. Number 3, real-time monitoring and diagnostics. Real-time monitoring and diagnostics. What's the function? It provides real-time data on system performance and potential issues. It provides real-time data on system performance and potential issues. The purpose is that it enhances maintenance and operational efficiency by enabling proactive management. The fourth and the last I'm going to talk about is the use of autonomous and remote operations. Function is that it allows for remote control and monitoring of DP systems from shore-based facilities. It improves operational efficiency and safety by enabling remote oversight and intervention. Next is crew operations. Crew operations on ships involve a wide range of activities crucial for the safe and efficient running of the vessel. These operations span various departments including navigation, engineering, safety, and cargo handling. Here is an overview of the key crew operations and responsibilities. The first is navigation and bridge operations. Under here, I'm going to consider watchkeeping. That is, crew members on the bridge monitor the ship's position, course, and speed. This involves operating navigation equipment, maintaining a lookout, and ensuring compliance with navigation regulations. It also includes route planning, that is plotting courses, evaluating weather conditions, and adjusting routes to avoid hazards or optimize fuel efficiency. This could also be in form of bridge communication, that is managing communications with other vessels and shore-based facilities using VHF radio, satellite systems, and other communication tools. The second is engine room and machinery operations. This could be in form of engine maintenance and operation, that is operating and maintaining the ship's engine, generators, and propulsion systems. It includes monitoring performance, conducting routine checks, and performing repairs. We also have auxiliary systems. that is managing and maintaining auxiliary systems such as water pumps, fuel systems, and HVAC, that is heating, ventilation and air conditioning. And finally, under this, I have watchkeeping. Engine room personnel monitor machinery and systems around the clock, ensuring operational efficiency and safety. The third is cargo handling as part of the operations of the crew, which could involve loading and unloading, that is overseeing the safe and efficient loading and unloading of cargo, including securing and stowing. We also have cargo planning, developing plans for the placement and securing of cargo to maintain the vessel stability and ensure safe transport. And it could also be in form of inspection and documentation, inspecting cargo for damage and ensuring all necessary documentation is completed and accurate. Safety and emergency procedures is also part of the crew operations. Uh, it involves emergency drills, that is conducting regular drills for emergencies such as fire, abandoned ship, and man overboard. This ensures crew are familiar with safety equipment and procedures. Number two, safety equipment maintenance, that is regular checks and maintenance on safety equipment, including lifeboats, life jackets, fire extinguishers, and emergency alarms. Number three, health and safety, implementing health and safety protocols to prevent accidents and injuries. This includes managing first aid supplies and addressing any health concerns among the crew. The fifth crew operation is stewarding and hospitality. This involves provisioning, housekeeping, and guest services. For provisioning, it involves managing the ship's provisions, including food, water, and supplies. It involves inventory control and meal planning. The housekeeping, it involves maintaining cleanliness and hygiene in crew quarters, mess areas, and other parts of the vessel. For guest services, it involves providing hospitality services if the ship has passengers, including meal service, cabin maintenance, and general assistance. The sixth is administrative and logistical tasks, such as record keeping, crew management, and compliance and reporting. Record keeping, it involves maintaining logs for operations, maintenance, and crew activities, such as recording navigational data, engine performance, and safety drills. Crew management involves handling crew assignments, scheduling, training. It also ensures compliance with labor regulations and manages crew welfare. For compliance and reporting, it ensures compliance with international regulations, including maritime laws and environmental standards. It includes preparing and submitting required reports. Number seven, communication and coordination. This could involve internal communication, that is ensuring effective communication between departments, including bridge, engine room, and cargo holds. External communication, coordinating with port authorities, agents, and other ships. This includes handling arrival and departure procedures and reporting any incidents or delays. Handling arrival and departure procedures and reporting any incidents or delays. Training and development. Ongoing training, providing regular training and development opportunities for crew members to keep up with the latest maritime practices and regulations. And certification, ensuring that all crew members hold the necessary certifications and licenses required for their roles, ensuring that all crew members hold the necessary certifications and licenses required for their roles. What are the modern innovations in crew operations? This could be digital tools and software, that is to streamline operations, manage data, and enhance communication. Examples include electronic logbooks, integrated management systems, and crew scheduling software. Improvement can also be in form of automation and remote monitoring. Function is to reduce manual tasks and enhance operational efficiency. Examples include automated cargo handling systems, remote engine diagnostics, and digital bridge systems. The third innovation is the use of enhanced training simulators to provide realistic training scenarios for emergency response and operational procedures, and also to improve crew preparedness and response capabilities. We have the crew welfare technology. The function is to enhance the well-being and quality of life for crew members, and examples involve improved communication tools, recreational facilities, and health monitoring systems. And the last concept I'm going to consider in the operation of ships is the technological advancement. Technological advancements in ships have significantly transformed maritime operations, enhancing safety, efficiency, and environmental performance. Here is an overview of some key technological innovations in modern shipping. The first technological advancement I'm going to be talking about is in automation and control systems. The first is integrated bridge systems, which combines navigation, communication, and control systems into a unified interface, allowing for better decision making and situational awareness. Next is the dynamic positioning systems, which automates the maintenance of a vessel's position and heading using GPS, sensors, and thrusters. It is essential for operations in challenging environments, and also the use of autonomous ships uh, that use advanced sensors, AI, and machine learning to navigate and operate with minimal human intervention, improving efficiency and reducing the risk of human error. Next is advanced propulsion systems. The use of electric and hybrid propulsion. This reduces reliance on conventional fuel by using electric motors or a combination of diesel and electric propulsion, improving fuel efficiency and reducing emissions. We also have the use of liquefied nitrogen gas propulsion and the use of hydrogen fuel cells. The third is energy efficiency technologies. Here I have air lubrication systems. The use of air bubbles to reduce friction between the oil and water, improving fuel efficiency. The use of air bubbles to reduce friction between the hull and water, improving fuel efficiency. Next is energy saving devices. This includes devices like energy saving propellers, fins, and rudder modifications to enhance hydrodynamic efficiency. And I also have waste heat recovery systems that capture and utilize waste heat from engines and machinery to improve overall energy efficiency. The fourth, communication and navigation enhancements. This includes satellite communication that provides high-speed global connectivity for data, voice, and internet services, improving communication and operational capabilities. I have also the electronic chart display and information systems. This replaces paper charts with electronic navigation charts, offering real-time updates and enhanced situational awareness. And the automatic identification system that tracks and provides information about vessel positions, speeds, and headings, enhancing collision avoidance and maritime safety. The fifth is environmental and safety innovations, which involves first exhaust gas cleaning systems, that is scrubbers. This removes sulfur oxides from exhaust gases to comply with emission regulations. It could also involve ballast water management systems that treat ballast water to prevent the spread of invasive aquatic species. Also, it involves advanced fire detection and suppression systems. That is, it incorporates automated detection, alarm systems, and various suppression technologies to enhance onboard safety. There could also be technological advancements in cargo handling and management, such as the automated cargo handling systems, the use of robotics and automated cranes for efficient loading and unloading of containers and bulk cargo. We have smart containers equipped with sensors for real-time tracking of cargo conditions, improving logistics and supply chain management. We also have the digital cargo tracking that provides real-time updates on cargo location and status, enhancing visibility and efficiency. Next is maintenance and monitoring technologies. This involves condition-based monitoring, that is, the use of sensors and data analytics to monitor the condition of machinery and equipment, allowing for proactive maintenance and reducing downtime. We have the use of digital twins, that is, virtual models of ships used for real-time monitoring, simulation, and optimization of vessel performance. We have remote diagnosis and support that enables remote monitoring and troubleshooting of systems, allowing for faster response and maintenance. Number 8 is crew welfare and training. I've mentioned a bit about this before. Under this, I have reality simulators, VR simulators, that provides realistic training scenarios for crew members, improving preparedness for emergency situations and operational procedures. It involves crew management systems also, that is, to streamline crew scheduling, training, and welfare management using integrated software solutions. I also have here the enhanced communication tools that offers improved connectivity and communication options for crew, including internet access and satellite phones. And finally, the sustainable technologies as part of technological advancement. This includes renewable energy integration, that is incorporating solar panels, wind turbines, and other renewable energy sources to reduce reliance on traditional fuels. It could also involve green ship technologies, which focuses on reducing environmental impact through innovations such as low emission engines, eco-friendly coatings, and waste reduction practices. These advancements are driving the maritime industry towards greater efficiency, safety, and sustainability. Understanding these principles provides insight into the complex systems and technologies that enable ships to operate safely and efficiently on the world's oceans and waterways. If you understand all these principles, we are going to have an insight into the complex systems and technologies that enable ships to operate safely and efficiently on the world's vast oceans and waterways. That will be all for now. Thanks for watching. So if you have any question on the operation principles of ships, kindly let me know in the comment box below. Or if you have other specific interests or you need more details on any of the concepts I've explained, please let me know.